Hello children, how are you all? Today we are going to study about rotational symmetry. Children, before we study rotational symmetry, we should know what is rotation. Children, I think you would have studied about rotation of Earth in your social studies class. What is rotation? Rotation is nothing but a type of transformation or a circular movement of an object around a center or an axis. Now, there are two types of rotation. One is clockwise rotation and the other is anti-clockwise rotation. From the figure below, we can see a clock where if the hand moves in the clockwise direction, it is shown by the blue arrow. And if it moves in the anti-clockwise direction, it is shown by the red arrow. And if the object looks exactly the same after rotation, whether it is clockwise or anti-clockwise, then we say that it has rotational symmetry. Children, we will learn some terms and their definitions used in rotational symmetry. Children, what will happen to the size and shape of an object when it rotates? It does not change when it rotates. The size and the shape will remain the same after rotation of the object. Now, the second point we are going to learn is what is center of rotation. You can see the figure beside there is one red point and that is fixed point. The fixed point about which an object rotates is called center of rotation. Children, before learning the angle of rotation, we have to know the angle of a straight line. All of you know the angle of a straight line is equal to 180 degree, and again below it is again the angle is equal to 180 degree. That means that the angle about a point is 360 degree. Now after knowing this, we will learn about angle of rotation. Now, what is the angle of rotation? The angle of turning during rotation is called angle of rotation. It is the smallest angle for which the figure can be rotated to coincide with itself. A full turn means a rotation of 360 degree either clockwise or anti-clockwise. A half turn means 180 degree either clockwise or anti-clockwise. A quarter turn means a rotation of 90 degrees either clockwise or anti-clockwise. So the next term we are going to learn is order of symmetry. Now what is the order of rotational symmetry? It is the number of times the figure coincides with itself as it rotates through 360 degrees. Children, now we'll find the rotational symmetry of a square. We will perform quarter turns about the center of the square marked by the red point. We find after every 90-degree turn, the square takes the original shape. This means after 4 turns or 4 90-degree turns, it comes back to its original position. That means since the square reaches its original position in 4 quarter turns, we say the square has rotational symmetry of order 4. Children, now we'll find the rotational symmetry for a rectangle. Rectangle is also a quadrilateral, and we are going to perform quarter turns for the rectangle. After performing quarter turns about the center of the rectangle given by the red point, we find that there are only two positions where the rectangle shows the same size and shape. That means we say that the order of rotation for a rectangle is 2 and angle of rotation is 180 degrees. Children, now we'll find the rotational symmetry of an equilateral triangle. You know, children, that an equilateral triangle has 3 equal sides and 3 equal angles. And the center of the equilateral triangle is given by the centroid, and each of the angles about this centroid is equal to 120 degree. That means when we turn a 120-degree turn, it again comes back to its original shape. Again we will turn another 120 degree, again it comes back to its original position. That means order of rotation for an equilateral triangle is 3 and angle of rotation is 120 degrees. Children, to know about rotational symmetry about some figures, we should keep some points in mind. The first point is center of rotation. The second point is angle of rotation. The third point is direction in which the rotation is effected, whether it is clockwise or anti-clockwise. And the fourth point is order of rotational symmetry. Here in the table, we have given you the shape, the center of rotation, order of rotation, angle of rotation, axis of symmetry for some figures. Please go through it and then you can make some paper cuttings of these figures and find out the center of rotation, order of rotation, angle of rotation, axis of symmetry. It is just like a game. Children, we'll find the rotational symmetry and order for some more figures which are not polygons. Here you can see in the first picture a flower. Children, is it not looking like a hexagon? And you all know that a hexagon has rotational order which is equal to 6, and it is shown in the figure. In the second picture, you can see that it looks like an equilateral triangle, and we all know that the rotational order of an equilateral triangle is 3. Children, in this way, we can find the rotational order and the rotational symmetry of different figures. Children, in your childhood, you would have played with the chakri or the paper windmill. Now we'll study about the rotational symmetry for the chakri or a paper windmill. From the figure or from the picture, you see that there are 4 positions in which the chakri shows similar size and shape. Thus, we say that the order of rotation for a paper windmill is 4. Children, today or now we are going to study about the difference between line symmetry and rotational symmetry. All of y'all must be knowing about line symmetry and rotational symmetry. Yes, the line symmetry means a line that divides a figure into 2 mirror images. Some figures have 1 or more lines of symmetry and some figures have no lines of symmetry. Then what is rotational symmetry? Rotational symmetry happens when you can spin an image around a point or an axis so that it retains its original shape and size. For example, let us take this example for a scalene triangle. We know that a scalene triangle does not have any line symmetry. Now let us find the rotational symmetry for a scalene triangle. From the figure, we have a fixed point A, and you can see one end of the scalene triangle is at point A. Now let us rotate it 360 degrees. It again comes back to A to retain its original shape and size. So we say that the order of rotational symmetry for the scalene triangle is 1. Children, we know for rotational symmetry we need a fixed point or an axis. But here for a scalene triangle we have no fixed point inside the triangle. So actually rotational symmetry of order 1 means it does not have any rotational symmetry. So this is the difference between line symmetry and rotational symmetry. Children, have you all enjoyed? Yes. Now today's homework for the day is find the order of rotation of these given shapes and also find the center of rotation on each of these shapes. Thank you, children. Have a nice day.